Okay, so we're back and we're going to utilize these uh, formulas to determine the type of conics in this next slide here. Okay, so here's a conic with the B term, as you can see. So we identify the A, B, and C terms. We go to the B squared minus 4AC. We do our computation, find that that's positive. So that therefore indicates that this conic represents a hyperbola. Okay, we take a look at this conic, 9x squared minus 12xy plus 4y squared plus 6x minus 8y equals 0. Identify the A, B, and C, put them into our discriminant form, and find it's equal to 0, which will indicate that to be a parabola. Here's another full expression, conic, A through F terms identified. Obviously, A, B, and C are easy to identify. Putting them into the discriminant form gives us a positive, telling us that we have a hyperbola there. And one other, so it's a hyperbola, and one other example, again, you might hear, I'm going to suspect we have a circle because we have the same coefficients and addition. So we're going to we're going to determine the B squared minus 4AC, which is going to equal a negative, which is going to be representing a circle. Could either be a circle or an ellipse, but since the A and C terms are the same, we're going to conclude it to be a circle. Okay. We have what's called the degenerate conic sections, which really aren't conics at all. So that's and you might not find out that until you go through and work things out. So we're just going to cite some examples here. So depending on the values of these coefficients, you may not have anything at all. So the expression 9x squared minus 4y squared equals 0 may look to be a conic, but in fact it's nothing more than two pairs of intersecting lines, the equation of which is 3 x and negative 3 x. You should validate that. Okay, this conic looks to be at first glance a circle, but it's nothing more than a point. So it's a circle of radius 0, and it's a circle whose it's a degenerate conic section. Again, not identified from its appearance at all, but might need to go through and work things out. There's really no fast-tracked way of determining that. You just might end up doing a lot of work and then find out at the last minute, unfortunately. And then here's another one, okay, which is another degenerate, which is really nothing at all. Sorry, that goes back. And again, you should validate those for yourself, okay? Next, we are going to talk more now about these conics requiring this rotation of axes protocol to reorient them with a new X and Y axes, okay? So they are, of course, terms which have that B term. So here we have the two, what we call two similar, they're same hyperbolas, okay? So the equation in green is given as here. And of course that is with a B term. And as you can see, the axis that contains its focus and its vertices is not parallel to either of the axes. So this is going to require a rotation of axes in order to align this up and end up giving us the curve that's shown there in blue. Okay, so the equation of the green is given. Okay, the line in red is the axis, and we want to rotate that. We'll end up showing, or you should be able to show after you go through the rotation of axes protocol, that the equation of that line is 1/2 x. So we have to rotate the our axes, our x, y axes, to a pair of x prime, y prime axes, which would give this hyperbola more in sync with the ones we're used to, okay? So the formula for that is given by this, the tangent of 2 theta, where again theta is that required angle of rotation. The tangent of 2 theta is the b value, which up here is 4, over the a minus c value. We'll do this. We just want you to know that formula. You're going to have to call on that. So after determining that that axis, that rotation angle, and then going through some algebraic formulations, we're going to come up with a new equation, okay, which is given here and is represented with the blue function, okay? And as you can see with that, that does not have the cross term bxy, and therefore it has been rotated into place where we can deal with it a little bit more, a little bit more to our knowledge of what we've seen so far. But the process of getting that new equation is rather detailed. So, and we're not going to go through the whole process, but we do want you to know how to find that angle of rotation. Okay, so that's what's going to come up here right now. So as it says here, we've aligned that. So we've taken the hyperbola represented in green with this equation, and we've rotated it through an angle which will be determined, okay, to put it in line with the axes, and then from which we could work with it from there if we so desired. Okay, so let's take a look. Okay, so we're given a conic here. We want to determine, first off, what type of conic it is, and then we want to see what angle of rotation is going to be required to put this in line with the coordinate x and y axes. So let's go through. We'll determine the quadratic or discriminant value b squared minus 4ac. That ends up being 400, and of course, since that's greater than 0, it is going to tell us that it is a hyperbola. And here is the hyperbola that is graphed, okay, through Desmos right there with that function, which is the same function as we have from the start here, okay? So that's no surprise to that, okay? Now, let's do the, let's determine the required angle, okay? So we use the formula, tangent of 2 theta is b over a minus c. Putting in the terms, we get the tangent of 2 theta is equal to 24 over negative 7, which therefore means we're going to use the inverse tangent to find the angle. So 2 theta is the inverse tangent of 24 over negative 7. So theta is half that, which is going to end up being, as you can see, roughly 38 degrees negative, okay, which is in the clockwise direction, okay. So here you are. Here's the axis. Here's the hyperbola been rotating, and here's the new equation. And of course, the new equation looks a lot simpler than the original equation, okay? And of course, there's no cross term, and in that we can typically find our you know, our a and b values and its center and everything else that we usually end up having to do. So now getting to that is going to be very detailed, and we're just going to give you the formulas for determining that new equation in the using the rotation of axes protocol. So using that protocol is to imply that we have one equation with, in this form, a x squared, so on and so forth, and we're looking for a new set of equations which is aligning our new conic with the coordinate axes. So as you saw in the previous exercise here, finding the type of conic and determining the angle of rotation is but one thing. That does not tell you how to get from this form, from this form of the equation to this form of the equation. So whereas we have new A, B, C, D's, E, and F's, and how we get through those is indicated here. So when the coordinate axes are rotated through an angle of theta, again using that inverse tangent of b over a minus c, okay, we come up with a new form of the equation where the a prime, b prime, c prime, d prime, and e prime are found using these sequence of calculations, of course, where the angle theta is what we found previous, the angle of rotation. So those will give you the required coefficients for the new equation, and you should try to validate that for yourself going backwards, using this as our startup equation and coming down to this as the equation in the rotated form, okay, using those formulas, okay. Rather detailed. I'm sorry I dismissed some of the development on that idea, or the but it's available in your textbook, okay. And it's kind of time consuming, but you do want to know that you can rotate the axes, and you do want to be able to determine the angle of rotation. Of course, once that angle of rotation is determined, you can define these new coefficients through these sets of formulas, okay? So there you have it, all right?